So seeing the rapid expansion of the IPv6 internet, we should pat each other at the back and say great job. So now let's start the working group meeting. My name is Xipeng Xiao, and together with Ron, we are co-chair of the working group. But today, Ron is having a medical treatment. So Eric Winker, AD, and also a delegate to our group, kindly agreed to sit in to help. Next page. First, I would like to remind you the IETF nowhere. I hope you are already familiar with it, but if you are a first-time comer, please at least know that we work as individuals and try to be nice to each other. Next. Two housekeeping issues. First, please scan the QR code to sign in with the blue sheet. And please also use your mobile to get into the queue before you walk to the physical queue. Next. Today, we again have a fully packed agenda. We have one working group draft and 5 individual drafts, followed with 2 very exciting operational presentations. I used to put the side meeting also here, but Zhu, IAB member, remind me that it's not good to put it in the working group agenda. So I removed it. But again, please know that on Thursday morning and afternoon, we have 2 exciting side meetings, and please come to attend. Next. The working group, the number of individual drafts, working group draft continue to grow. So I think that this is a good sign. But due to more working group draft and individual draft, I also feel that the chairs are a little bit fallen behind. So we hope to do some more actions to speed up the process. So we'll try to take some action. And again, I would like to remind everybody that we are here to solve IPv6 operation issues. And these include the lack of motivation, lack of knowledge, legacy devices, and some operation issues. Next. So I would like to, again, call for everybody's contribution. First, to Brian's book. Now we have 12 contributors and 410 commits. So compared to the previous IETF, we have 2 more contributors and almost 90 more commits. So I think that it's a good sign, but this is a very important piece of work to propagate IPv6 knowledge. So we hope more people can contribute. Justin just issued a survey for extension, the usage or the policy regarding the extension header. Please help him. This will help us understand the extension header, which is an important issue. Please continue to support Nalini and Mike on the enterprise IPv6 deployment issue. And there are some other tasks that may be useful to do. For example, the IPv6 packet loss rate. Can we measure them? can we clearly articulate the advantage of IPv6 other than more address? And now we also know that IPv6 have another big advantage, which is like on worldwide average, it has lower latency than IPv4. But anyhow, we need to be able to clearly articulate the advantage in order to convince more people to move on to IPv6. So with that, we will move on to our first Jeff presentation. We'll start with Jeff.
I seem to be about 5 feet too tall for that mic. I'm Jeff Houston, and I'm the co-author with Nick on this particular draft. It shouldn't take long. The reason why I'm here is actually not because this was my idea, it was Nick's, but because I was the co-author of the previous idea, RFC 13849, I think with Philip Smith, that did a V6 documentation in the RFC series. Next slide. So back in 2004, that was published, and it actually cleaned up a rather bizarre situation where, to my knowledge, both APNIC and the RIPE NCC had actually reserved V6 prefixes but hadn't really told anyone. And they were sort of lying in the registry going, this is for documentation, but it wasn't a big thing. And we thought, you know, well, maybe we should, a bit like RFC 1918, actually come out and say, this is a private use address prefix and actually coordinate across the entire community, which we did. It was a /32. And at the time, yeah, it's kind of interesting. It was a relatively conservative choice. But what we've found, of course, is that these deployments of V6 are now pretty massive. And a 32 can't describe almost any realistic deployment now. So if you're trying to document a typical network in V6, a typical operational network, you can't use this documentation prefix as is. You've got to lie about prefix sizes and make things artificially small so that the total sort of documented example doesn't overflow your /32, or you've just got to borrow some more addresses. And if you're borrowing some more addresses, why have a documentation prefix? So it seems that a /32 is actually too small. Next slide. So one of the ways around this is to go, let's just do a /20. It's not the biggest customer assignment that the RIRs have made. A number of folk have had /19s, and you know, there are some big networks out there. So it's not completely over the top, but it's certainly comparable to the larger V6 deployments. You go, well, that's massive. Yeah, but so is V6. 4,096 32s is in a /20. And the current pool, which we're operating out of, which is 2,000/3, has 536 million of them. So this is literally 0.00076% of that space. Itsy bitsy teeny weeny. So it's not really, oh my God, all that space. It's actually a relatively tiny amount of space in a /20. Next. So the idea in 2004 was, you know, that'll be big enough, won't it? And I'm saying to you now, well, you know, it's big enough, isn't it? I don't know. You don't know. None of us know. But it does seem unlikely. You know, I'm not sure how much the fantasy of the Internet of Things will get real and to what extent the silicon industry is going to go completely berserk on us. But quite frankly, we haven't done many /19 allocations over the last 20 years. They are very, very rare. And now that we've moved away from fixed /48s per site, and operators are actually making differing and variable uses of their prefixes in the way they actually allocate them through, most networks seem to fit inside a /20 comfortably for most examples. So a bit of optimism, a bit of reading the winds. We think this is good enough. And if we're wrong, we'll be back here again in 20 years' time, or someone will, I'll be dead, going, oh, we need more. But let's cross that when we come to it. So this is kind of going, this is reasonable for documentation as it sits right now. I think that's the last one. It is the last one. There you go. So I'm done. It excited more comment on the mailing list than his exciting comment here, oddly enough. But we'll see.
Jenikova. Thank you. Thank you, Jeff. I've always been suffering because, yeah, when I'm trying to draw a network diagram, I did not even think it's possible just to come here and ask for more. Thanks for doing this.
You've got to thank Nick.
Thank you, Nick.
Thank you,
I
Nick.
hope you're listening.
Yep, I'm here for the ride.
Good. So, yes, I think it's a great idea. You're absolutely right. We'll deal with that if you need more. I hope we are not going to run out of IPv6 address space in the next like 500,000 years. And even if it's like 250,000 years, it's probably not such a big problem. So yeah, let's do this.
Thank you. I wasn't keeping track, but somebody is somewhere. The tool is. Antonio.
So about 10 years ago, I presented about the same idea, the same RFC, and you came to the microphone and lectured us about how it was useless and how you regret to be the author of the first RFC. And you told us that there was no problem in using global addresses to do documentation or anything else where we can use this new idea. So what changed? What changed from 10 years to now? You convinced us and we abandoned the idea, and we are using global space to do documentation and testing and teaching and so on for 10 years without a problem. So probably you were right then.
Well, you know, thank you for pointing it out. I'd completely forgotten. The beauty of human life is we tend to learn. And if you don't, then you're stuffed. And I would actually say for me, it has been a learning experience over the last, 15, 20 years, however long it was. And I suppose with more familiarity with the patterns of usage of V6, there was a period, and I think I can put it down to 2005 to 2008, where we all got very concerned about the combination of the HD ratio and /48N sites. And what we were seeing, and I think the best example was Telia Sonara, that had a deployment of less than 7 million subscribers, but they wanted a /19. And under the rules, they kind of got allocated a /9. And we're sitting there going, wow, if everyone does that, we're going to reach the end of the barrel a lot faster than we thought. And so around that period, we kind of backed off into the conservatism of V4. We changed the N site boundaries. We actually ditched a fair deal of the HD ratio, the way it was being applied. And I think there's now more confidence in those V6 address pools. And as Jen said, in some ways, I think most of us on the addressing side of the world would say, as far as we can see forward, 10, 20, 40 years, there's no looming, scarcity on the horizon that we can point to. So maybe just attitudes change and we're learning more. So, people change. That's a good thing, by the way. My 40-year-old self was wrong on almost everything. You should never have listened.
We don't.
Thanks, Warren.
Who's next?
That's your problem, not mine.
Hi, Bob Hinden. I'm fine with this. And my main observation is that isn't it nice we need to do this? That we're seeing a lot of large deployments that need to be documented.
Totally. Thank you. Yes.
So Warren Kumari, my main observation is it'll be really nice to have a documentation prefix that's clearly different to the existing documentation prefix. Because like when reading documents, it's really easy to get lost, like which one of these.
I know we were kicking ourselves that we didn't actually get D0C0.
Oh, that would be awesome.
That would be awesome, but it's in the IANA considerations as a TBD. So if some friendly AD wants to kick the IANA when they sort of look at this going, D0C0 is actually not a bad idea, that would be a good thing. some random AD.
I mean, I do actually think that it might not really be a bad idea to ask for an initial small one, because like when you're reviewing a document and everything starts with the same prefix, it's really hard to keep them separate. So if you asked for this and another small, you know, something, so that
You've
it's
already
easy to
got a
keep them
slash
separate.
32.
Sure, but that's 2 of them. Anyway.
Yeah, Ray Bellis, ISC. Yeah, Jeff, you're right. It's a tiny amount of address space in the grand scheme of things, but I also think it's completely unnecessary to actually burn any global space for this at all. I mean, we're all technical. What's wrong with XXXX:/16 in documentation and normalizing something like that? We're used to using placeholders to mean this is some arbitrary /16.
We've run into problems with extreme literalism, and APNIC does do some teaching. And
Yeah,
certainly
but-
it's interesting that folk will literally transcribe the slide, put it into a working machine and wonder why A, it's not working, or B, they've just caused havoc
Sure, but
everywhere.
that's why I
So
use
liter-
XXXX rather than something's not actually
But
legal.
they'll type it in and go, that's wrong.
And they'll learn something.
Well, hopefully.
Yeah.
But you know, that's the reason why we do this, to try and sort of make it real, make it workable, but let everyone else in the world know, don't route this crap, it's the documentation prefix. So that was the idea behind it.
Lorenzo, clearly, I do think this having such a large allocation isn't really necessary, because there are networks that have more than this amount of space, and there's also networks that have multiple prefixes, and you can't do that with this, right? So for example, the Google network, I think, has 6/32s or something, one from each RIR. Okay, well, maybe that one comes from Antarctica, I don't know, but anyway. but I think that's also something to think about. I think maybe having fewer smaller ones might actually be more useful in terms of documentation.
It's a view. Probably we can discuss it on the mailing list. I actually like that this is the large block single allocation. It's really easy to filter out. There's very little uncertainty about this block is non-routable. How you divide it yourself in documentation is kind of up to you, but it's a one-line entry and a filter list, which makes that part of it just so much easier.
Okay,
We exhausted the line. Thank you very much.
thank you, Jeff. So let's move on to the next presentation. Yeah, Vladimir. What? Yeah, let me start the timer.
Which way? Okay.
Good afternoon. I'm going to be talking about the transitioning technology. Why another transitioning technology? I will address that later. For now, it's because we will need it. So this transition strategy is based on a different principle than anything that is used right now. It doesn't need IPv4 addresses, doesn't need IPv4 internet during transition, right? It transitions to pure IPv6, and it needs only pure IPv6 internet. This is based on IPREF, which is an end-to-end address space traversal. So this is not like a specifically transitioning technology. It's another technology that is just used for transition purpose. This is a very brief overview because I don't want to talk about IPREF. I want to talk how it is used for transitioning. But there are some key things here that need to be understood. So IPREF traverses end-to-end over NAT, NAT6 filters, and cross-protocol IPv4, IPv6. Stateless, massively scalable. Important thing to understanding is that it uses special addresses called IPREF addresses, which is a combination of 2 items. One is the context address, which must be a native address, and the reference, which is really some number, an opaque integer. Some examples below, 192.0.2.123, and the plus sign separates the reference. And in the IPv6 case, so it would be 2001 db8 : 123 plus 2371. And finally, the important characteristics of IPRF is that those addresses are publishable in the DNS. Not working. Oh, it started working. This is one slide that briefly shows how IPRF works. Again, I don't want to spend too much time on this, but there are things that we need to know. This is a busy slide, so let me guide you through it. At the bottom, there is a network diagram. It's pretty simple. There is internet in the middle. There's a network A on the left, which has a IPRF gateway and some hosts. And there is a network to the right, which has its own IPRF gateway and some hosts. The way IPRF works is similar to standard network protocols. It uses source and destination addresses, which are the same as it travels through the network. So this is shown at the top line. So the source is 2001 db8 9 plus 1979, and the destination is 2001 db8 : 8 plus 2466. And it is the same thing when it gets to the internet, and it is the same when it gets to the target network. What happens, I mean, to make it work, those IPRF addresses are interpreted in each address space. So in the network A, it is interpreted as an IPv4 address of the host A1, for example, and the destination is some fake private address. In the internet, references make no difference, so they're ignored. And in the destination network, those same IPRF addresses are interpreted again to something else, where the source is some local private fake address. By the way, this is that address is the feedback to the previous presentation. I need to make a point that this is a private network. So maybe documentation can consider that. So anyway, so it's on a private network, and the destination is the address of the host. Okay. I think it kind of works. I just have to press two buttons on one. So transitioning, this is what I want to talk about, how the transitioning works with IPRF. So there are two diagrams here on one slide, just to conserve the space. So the starting point is all IPv4. So the IPRF gateways are installed but not used, so the traffic goes pure IPv4 with IPv4 addresses for destination and source, and DNS returns pure IPv4 addresses. The first thing to do is to switch to the IPRF. So the source and destination will get their own IPRF addresses, and the gateways are installed. So now the same IPv4 traffic, still IPv4, goes through the IPRF gateways. Now there's an important thing that is happening here. The gateways decouple those address spaces so that network A can start transitioning right now, right away, without worrying what the network B is doing, and in fact, regardless of what the internet is or whatever internet is doing. So this is with the dash line IPv6 is shown. Maybe somebody wants to start setting up IPv6 network. It's a pure IPv6, even without connection to the IPv6. It works in that. Okay, next. Okay. So eventually, network A does get internet, IPv6 internet, and it can start transitioning for good. Notice that it doesn't have to wait on network B. So it can set up some server on its IPv6 network, and the local IPv4 client will be able to reach it. and the remote IPv4 client will also be able to reach it. If IPv6 has a client, it can reach a server on the local IPv4. It can also reach a server on IPv4 on the remote network, and it wouldn't even know that this is IPv4. So this is a case like two networks, network A, network B, but in reality, in a typical enterprise scenario, you would see like 20 of them, maybe 200 of them. So that step 3 is repeating several times. Eventually, some of them will also connect to the IPv6 network, and then we can go through the IPv6 internet to the very same IPv4 server on the right, or maybe the same client IPv4 on the right can be accessing another server on IPv6 on the left, or maybe another IPv4 server on the left, but this time over IPv6. And this is an important point here to notice that the network B is running IPv4, but it does not have IPv4 global address. And it does not need IPv4 internet. And it is not needed during the transition, not after the transition. Okay, next. Okay. This is the point where if you have those involved networks connected to IPv6, you can actually drop IPv4. And you can sell your IPv4 addresses if you want. At this point, transition is complete as far as internet is concerned. And notice that enterprises, they can still continue with their transitioning at their own pace. And again, this is two networks, but there may be 20 or 200 of them. And yeah, whatever is done on the right side doesn't affect what is done on the left side. They can just progress at their own pace. So eventually, some of these networks will convert to IPv6. So we have IPv6 on the right side. On the left side, we still have some IPv4 that we want to hold on to for a while. It doesn't matter. It's still everything works. And eventually, all of those 20 or 200 networks do convert to IPv6. So at this point, this is really complete, not only from the internet point of view, but also from the enterprise point of view. You may wonder, should we drop IPref gateways? Yeah, you can drop IPref gateways, or you can hold on to them because you never know what other site is going to show up that is not transitioned. Next. Now, IPref works on different principles, and because of that, it will succeed where other technologies, the existing technologies will fail. And there is like 3 cases where this will happen. Chiefly among them is taking down IPv4 internet. I don't think the existing technologies will ever eliminate IPv4. They rely on IPv4. Dual stacks, IPv4. Not 6.4, IPv4. 464X at IPv4. Not only that, you also need IPv4 internet for them to work. So they will never be able to do away with this. Therefore, I think such technology like IPref will be actually needed to complete the transition. That's because IPref does not need IPv4 internet, doesn't need IPv4 addresses, and you can drop it early, not after the transition is done, but when the transition starts. Another case is enterprises where the coupling of transition effort from peers is hugely important. This allows to work at own pace, lower cost, lower risk, and the cost is a really, really hugely driving force at the enterprises. Pure IPv6, another thing. Nobody wants to do dual stacks and do the transition again. This is just unnecessary. I also mentioned there's ISPs. For ISPs, I mean, you can live with pure IPv6. And there was like in the beginning of the session, there was a question, how do we advertise IPv6? Because we have more IP addresses, because it's got slower latency. You have to pay attention to that because you have to win over IPv4 somehow. So the fewer stuff ISPs have to do, like IPv4 as a service and that sort of things, the better. And eventually procrastinators, there's simply a lower threshold for transitioning with IPref. Okay, that's all. No, let's get back to any questions?
Warren Kamari. I think the document would benefit a bunch from some comparisons to things like Lisp or HIP or something which do some very similar things, and it might make it a lot easier to understand.
I guess, sure, my answer is, right now I just wanted to present another approach.
Jerlinkova, to be honest, I'm slightly confused to why you don't need to call IPv4 internet, because I guess your devices inside the system will still need to reach like Twitter and other resources. And just for sake of time, yeah, I agree with Warren. It would be nice to compare with other things, because I'm not sure why people would choose this over technology which already exists and tested, right? Because my main concern would be if you start turning off IPv4 inside, your main problem will be that application on individual endpoints fail without v4, right? It does not matter what your gateways do. And the third comment quickly, if network A, network B are kind of on the same administrative domains, I can understand how it scales, but how does it scale globally if your draft mentions like tunneling between gateways? It's going to be what, full mesh? Or you envision some hierarchical approach here? It would be like interesting to see how you see it like working at the global scale.
Okay, number one. So this is the diagram that is showing again, and the network B runs IPv4. This is the IPv4 behind the NAT, so to speak. So this would be running something like 10/8 network. It does not need IPv4 global address because IPref gateway will carry over IPv6. I mentioned earlier that IPref traverses NAT, and traversing NAT is hugely important in this. You are correct. If it was unable to traverse NAT, then IPref will not be able to do away with IPv4 internet. But because it can, IPv4 could be eliminated. Question two, what was question two? No? Okay. And can you please ask in a mailing list? Yes.
Lorenzo, do you want to continue, or do we take it to the mailing list?
I just want to say, look at whether this makes any sense from a commercial and deployment standpoint, because the IPv6 transition is just almost half done, and I don't know that this solution could be implemented and commercialized before that's done. So if you have another, and also I think the costs of keeping IPv4 running aren't that high, because organizations kind of have the same dual stacked approach. It's not very, very expensive for them to keep doing it. It's more expensive than single stack, but we kind of do have single stack solutions for people who want to run them. So I think, yeah, if you had another, if this was available 15 years ago, then maybe we'd have gone with it. But I think you might, if you want to push it, you might want to find a different goal for it than the V6 transition. Because that, I think, is on rails, and people sort of understand what there is to be done, and it's just a question of when they do it.
So I guess in the future, you seem to be saying that existing transitioning technologies will succeed in completing the transition, whereas I am, in my analysis, I don't believe this is going to happen. I am also saying the cost for enterprises is hugely lower with this than without it. So consider 2-3 years from now, you may say, yeah, we're sticking to our horses, okay? But when the enterprises smell that they don't have to go through this ordeal, that they can make it cheaper, that they can transition to IPv6 directly without the two-step, transition. That they are not forced to transition every single network that they don't want to. That they can decouple their effort from other networks. Actually, I remember the third question from Jen. So,
sorry, Vedma, because we are running out of time. Maybe I think that you can just listen to other people's comment and then think about it. Maybe respond on the mailing list.
Okay.
David, you want
Thanks.
to?
I'll make it quick. David Skenazy, IPv6 enthusiast. So first off, I want to really thank you for writing a long introduction to this draft. I think it did a really good job of comparing what transition technology we've had and the problems there. I think, however, if that analysis fails to identify why most new transitioning technologies have failed, and why this one I think will the same way, is that we don't need a new transition technology. If you ask everyone in the room, they could design their own transition technology. But the main problem is we're transitioning to IPv6. It won't make it any easier to instead have to transition to IPref or IPv10, or my personal favorite, just run everything over mask. That way you don't need to care about IP addresses. But like none of these are really deployable. And that's the fundamental problem, is just we don't need another transition technology. Thanks.
So again, it's a conjecture and a prediction of the future. You cannot make that.
Okay, Vedma, we need to move on. Okay. Tommy.
You share yourself? Yeah. Sure. Do you see the request in there? Yeah. Very good. Thank you.
All right. Hello, everyone. Good to see you. Okay, so I'm here to talk about happy eyeballs. And happy eyeballs is hopefully a familiar topic for many of you here. It is something that was originally developed as a document in RFC in V6OPS, and then we did a BIS effort several years ago. And now we're here to BIS the BIS. And we're V3, and now we have 3s with very happy eyeballs on them. Sorry for bringing this icon back for those of you who remember that. So in this, David and I, who had previously written the BIS document, are also joined by Nidhi and Kenichi, who are helping us work on that. They are from Google Chrome networking stack as well. Okay, so I think the main question is why would we need another version of happy eyeballs? What has changed? And I want to emphasize that the core of the document, the ethos, is all the same. And we started this by wholesale copying the entire document, had to update it into Markdown and everything else. But it is fundamentally the same document and the same algorithm as V2, but with some changes to deal with the changing landscape that we see in terms of DNS records and also the transports that we're able to use. Now, this doesn't fundamentally change the emphasis on using V6 and trying to promote V6 and have this adaptability, but there are some deployment and operational considerations that make this different. The biggest one is that we have to deal with an entirely new DNS record type that can get us information that will influence the race. And actually, the SVCB RFC actually just came out today. And so this is now very much official, even though we've been deploying it and requesting these queries and getting the records back for several years now. And so this is a new record that, alongside A and Quad A records, can give us address hints, so it can give us both V4 and V6 addresses back. So it's a new source that we need to deal with. It also has priorities, which is something that otherwise would not be incorporated into the Happy Eyeballs algorithm. And it can also tell you things that are less directly related to addresses, but still may influence which connections you prefer to have in your race. We also have the fact that I think Quick was around when we did Happy Eyeballs initially, but it was twinkle in somebody's eye, and now it is a full standard. And the original Happy Eyeballs was very much written in terms of TCP. You race the TCP connections, and everything's based on the TCP retransmission timeouts. And for the modern age, where we have quick alongside TCP so often, we thought it would make sense to rephrase the document in terms of more generic transport handshakes as the things that end the races. And there are also other things that SVCB brings up, like security features like encrypted client hello, which, while they do not directly relate to some of the timing impacts, give us good input of saying when we are doing our race and we are trying to select different addresses as more preferred over others, if we know that some of them support stronger or weaker security features, that may also change the algorithm. So we can't have the algorithm be naive to different security postures of different addresses. So this is mainly just for reference if you're not familiar with the existing algorithm. Previously, you had a couple different steps. You would query A and quad A DNS records. You would send your quad A, maybe, if you had to send them in order, send that one first. Once you get back the addresses, you sort them based on various algorithms, and you stagger your connection attempts. And Happy Eyeballs v2 had you put 2 v6 addresses up first and then a v4 address, and then you kind of alternate from there based on your assumed preference on your client implementation for a v6, although you could be different based on historical data. And then you would race until the TCP handshake completes. So for cases where you have these new third records, these SVCB or HTTPS records that you're requesting, you're going to now request 3 DNS records in parallel. That if you are configured to do that, the other way still exists. And you now have SVCB priority, which can assign to different services and essentially different pairs of A and quad A records or v4 and v6 addresses, different priority strata. And that needs to influence the order and our ranking algorithm for Happy Eyeballs. And as I mentioned before, there may be different security postures, and that may need to impact things. But then from then on, it's generally the same overall approach. We just have new inputs to the DNS resolution stage and new inputs to the sorting algorithm. And the other difference is that when we're talking about when do we complete the race and when do we say, yes, this address won, it's important to include quick in that, but also bring up the point that you may want to race until, if you're doing TLS to a TCP server, that you may want to race until TLS completes. And I'll kind of deviate from the slides a little bit here to tell you an interesting anecdote that we hit that really is very much related to V6 breakages when we were doing Happy Eyeballs, but we were not racing all the way through TLS, because there are on some carrier networks, for example, TCP terminating proxies that are transparent, and you do not know you're going through it, but will you're going to the correct addresses, and end host is dual stacked, and you think you connect to it. They terminate TCP to make sure you have a very, very fast TCP connection. You then try TLS through that, and the V6 addresses on this proxy are busted. It does not work. And it's very, very, very sad. But you can think that your Happy Eyeballs is working, and you can essentially have broken V6 connectivity. So this is one of the things that we've learned over the past couple of years that tells us, maybe we need to update this. And even though it seems like a little bit of a higher level thing, it comes back down to all the pathological ways that V6 connectivity can very sadly be broken. So interesting things to learn. If there are other learnings that people have that would impact the algorithm, we'd love to incorporate that. So here's what's currently in the draft for the sorting algorithm. I think this can have some debate and some work on it. I think there's already some stuff on the list, and we've gotten some good issues on GitHub. So we'll continue to refine how things should work in this case, but the problem has gotten a little bit more complex, and we need to take more things into account. With regards to generalizing for quick, I think I've hit on some of these already, but we may also want to sort things based on preferring services that have more capable ALPNs, because that may be an overall faster connection. So that may influence how you bubble things up when you're racing. And we had to adjust a lot of the other text to generalize beyond just TCP. For the ECH considerations for security, there are different options that you can be within the SVCB document. You can be SVCB optional or mandatory, and there's some interesting consequences that come from that. So this is what's currently written in the document. We'll continue to review that and continue to refine it. So for the next steps here, we've already seen some great active engagement on the list on issues. We'd love to keep getting feedback and keep refining this. I think this is a discussion that we need to have. As far as implementations, for the past several years, the Apple stack that I work on has been sending out the SVCB queries. And so we've built that into our Happy Eyeballs logic, but some of these other nuances around how you deal with these security connections or other ALPNs are things that we haven't fully adapted to what's in the draft. And so this is something where we want to see more go on. And I know that the other authors on this draft are interested in implementing and having that become feedback into the draft. So encourage anyone who has a Happy Eyeballs v2 implementation to consider how this would impact them or potentially update their implementations. And then I think question of if this group is interested in adopting, I know there's some discussion of, is this something that makes sense here or not? I personally believe this still fundamentally is about getting V6 more deployed and having better working connections. And this is a group that has a lot of expertise there, but happy to hear other opinions. All right, let's go to the line, Jen.
Jen Minkova, first of all, yes, good job, let's adopt it. I have a question. I have a question about section which apparently was inherited from the previous version of the draft. Are you willing to make changes about section regarding V6 only network support?
Yes.
Because basically the draft currently mention how to detect that you are on such network. First of all, shameless plug, I just submitted a one-page draft about doing exactly that. As an author of Prefix 4 FC, I'm curious if we shall recommend looking at array option before doing 7050, right?
Yep.
Because it will be faster and more secure and so on. And second question about V6 only, I just realized you're saying that, yeah, please do not limit number of DNS resolvers you are using. So question is, would it make sense? I just don't know the answer. If you detect both DNS and DNS 6.4, prefer DNS over DNS 6.4 in such case? Because if you're going to do synthesis yourself, why?
Yeah. Why? That's a great point. Thank you for bringing up. I think completely in scope, and like another one of those things I should have listed on the first slide of like how the world has changed and evolved. And I think we already had one PR issue to improve some of the Pref 6.4, but I think we can do far more there. So please file the issues or let us know what we should do. Totally agree that's in scope, and I think that would really help the document.
Jan George, I think this is fine. We need to update the Happy Eyeballs, but I would like to add something else that we should probably start thinking about. In the operational world, Happy Eyeballs is saving the users from the bad user experience, and that's fine.
But hiding the problems.
But there are many IPv6 implementations up there that are fundamentally broken. And how can we start putting mechanisms in place that still saves the user from the bad experience, but also somehow tells the operators that their IPv6 implementation is broken and they need to fix it?
Just turn off IPv4.
Well, yeah, that was my idea also, but then you would end up with many broken implementations. Right?
Yeah, and I think this was also brought up on list. I think Jordi was talking about that, and I totally agree. As I said on list, I think that there is room for the core Happy Eyeballs algorithm document to stand alone and then refer to other documents about ways to hopefully report the brokenness. And I think I would fully support those being developed together. But I think there will definitely be a world where clients can independently update their algorithm, and then we need to work on negotiating with networks or end hosts to be able to report breakages that are detected by the client.
Lorenzo Colletti, yeah. So one thing that I don't know, we might have thought of already, I'm sure, but racing until TLS is established has also a pretty good chance of like finding and defeating MTU black holes. So +1 on that. Because,
Yeah,
you know,
great
if you
point.
have like some
It's very
big
true.
cert that comes down the pipe and it doesn't work, then well, that's connection is not going to be preferred. I'm going to say that I don't think this belongs here, not because I don't think, it's not like, oh, get off my lawn, but but I actually think that the interesting parts here are not about IPv6. There's a lot of experience with IPv6 in this working group, but the interesting parts here are things like, well, we waited X milliseconds for the SVCB, and now we might have the choice between doing something less secure. What do we do? And I think the expertise in that is more sort of, I feel around like the transport area and the security folks. I mean, like not here, right? So the V6 stuff, I mean, like, if all you wanted to do was IPv6, I think Happy Eyeballs V2 is kind of a reasonable approximation, minus the TLS thing, of course. But anyway, so I would think that you want to, this is super important, and it needs to go to a place where you've got the expertise to answer all these hard questions. And I don't think those people are here, but that's just my opinion. I don't feel super strongly. But, yeah. So the other thing, by the way, is that you cannot implement this with an IP stack. You need something that looks like Apple Stack or Chromium or Cronut, right? The Android could not implement this because it doesn't have the stack itself. You need something that's much higher level. And so again, yeah. And again, it's sort of like
you need the DNS and TLS/quick layer.
Yeah, you need something that's rolled all into one. Yeah. Anyway,
Agreed.
so
Agreed.
and yeah, the other thing, I'm just curious, like you, for example, that's probably addressed, but you run SVCB lookups in parallel to A and quad A, but the SVCB tells you what priority those other two are. Just out of curiosity, how long do you wait?
Right, that's in there. Like we have, like it's additional timeout value that we recommend, just like the other ones. Yeah, so thank you for that. I'm not sure where it would really belong other than here. And like one thing, like I loved what Jen pointed out, like there are other things that have changed that really are V6 expertise that we want to incorporate, and I don't want to lose those. So like at the very least, I want this group to be heavily involved. And then I'm not really sure because like it doesn't, I want DNS experts, I want security experts, I want transport experts, I want int experts, like it's ops, like it's kind of everywhere. So I don't know where that belongs.
You kind of want a working group that's inter all of the areas.
We'll just take it through Jen.
Jeff Houston, Lorenzo has actually sort of started the conversation, which I think is important.
Yeah.
Because the original idea on Happy Eyeballs was we knew from the start that V4 wasn't going to magically just go away. And previous transitions, what we'd found is if you had a preference to the one you want to go to, and you use the other one only second, then the old one would just die, because the more you sort of permeate the new one, if you're preferring to use it, the other one just disappears without any positive action. What we found, though, was waiting for a connection to fail was taking up to 3 minutes. Users don't live that long, they die.
Yep.
So, you know, along comes Happy Eyeballs that say, drop 3 minutes to a few milliseconds, everyone's happy. And kind of right. But what we've done since then is we've created a much richer layer of communication between alternatives, alternative transport protocols, not just address families, alternatives in the way that first connection is set up, the security and TLS and so on. And now you've said, and you're saying, well, this Happy Eyeballs is actually kind of cute, because in some ways it's a case of preferring amongst alternatives.
Yes.
So let me generalize. But at this point, you've strayed from the reservation. This is no longer an A quad A address family choice. And it's quite a reasonable thing to talk about, because when you start offering alternatives in SVCB and you're trying to sort of negotiate between a client and a multiplicity of potential servers, a multiplicity of transports and a multiplicity of security, you know, arrangements, how do you make an optimal choice that works in the interests of the user? More power to you. Where the hell do we discuss this? And, you know, kudos to this group of having a very wide range of experience across all of those areas, but we don't. And it's not really a V6 transition argument anymore. It's actually an argument about the mechanisms of rendezvous to try and make the next packet you send the best one.
Exactly.
And that's actually a really hard decision and a really hard area. And this is looking promising as a way of doing it. Is this the working group is actually a really interesting discussion about, are we missing bits in security? What you don't want is to half set up a whole bunch of state and then rip it down again because it wasn't the best choice. That just puts burden and sort of load elsewhere. And that's not necessarily in the network's interest, let alone the user. How do you optimize lightweight, but the right answer?
Right.
And I'm not belittling it. I think it's a really hard problem. I'm just not sure that this working group is the place where you finalize that. These are great ideas. They can't die. We've got to do something. I agree. I just don't know where. So it's echoing Lorenzo.
Great. And to the last points you made, lots of thoughts there and lots of stuff we've done.
Tommy.
Yes.
May I ask you to just listen, because we really need to move on. I would like also to ask Julius to be concise. And we have to cut up the queue. Sorry, Philip.
I'm just saying, I just think that now that you have priorities and multiple transports and exciting stuff, you're a very brave man, Tommy. Now that you have all of this stuff, it's starting to look a little bit like a subset of ICE. ICE. Yeah. And I'm wondering if it wouldn't be worthwhile to have it reviewed by someone who has serious operational experience with ICE.
We have.
Okay.
Do we have more in the queue?
No, Tommy, we
you're
need to move on.
Great,
Yeah.
perfect. Okay, great. Lovely. Thank you. Thank you.
Could I say one word?
Okay.
Could I say one word? Transport area working group, just saying that that draft's all going to be presented there in transport. We're going to give it 10 minutes to talk about it. And I would love to see the transport people comment on it. I think it might belong here, but we can work together. So let's just see how that works out.
Okay. Gabo.
Hello, I'm Gabo Lenche from Hungary, and I would like to talk about the scalability of IP version 6 transition technologies for IP version 4 as a service. And the aim of this draft is to provide network operators with information about the scalability of various implementation of different IP version 4 as a service technologies. And the methodology is that my students or I perform some measurements complying with the with the RFC 4219 measurements, and we publish the results, and we just add a summary of the results to this draft. And this is how this draft is being evolved. So the first significant part was the scalability of the Joule stateful NAT64 implementation, which can be used together with DNS64 or as a PLAT of 464XLAT. And there we measured the performance, three performance characteristics, such as the throughput, which is well known, and two new stateful specific characteristics, such as maximum connection establishment rate and connection teardown rate, which are specific to stateful technologies. And what do I mean scalability? Scalability can be measured against the number of CPU cores, how the implementation's performance scales up with the number of CPU cores, and the degradation against the number of concurrent sessions. Maybe this is the most important of them. So various, oops, it doesn't step, I don't know why. Could you help me? Thank you. So there were various phases of this draft. I don't want to talk too much about the history of the draft. Currently, I would like to talk about the scalability of OpenBSD PF. Could you go to the next? Yeah, thank you. It works. So why OpenBSD PF? OpenBSD focuses on security, and the developers are very proud of it. And PF, the package filter, is a firewall of OpenBSD, which can do stateful net 6.4 for more than 10 years. And we tested the version of OpenBSD 7.1. And this was the measurement environment, just two general purpose Dell servers interconnected by 10 gigabit Ethernet connections, direct cables. And these are the results. So maximum connection establishment rate, it means that we use different number of connections, 400,000, 4 million, and 40 million. So the number of connections were always increased tenfold, and it was achieved by using the same IP address pair and fixed number of source port number, and the destination port numbers were increased. So it was the size of port number ranges. And you see the median here is scaled down somewhat, but I think that the degradation is acceptable. Just you see 29% or 13% is acceptable when you increase tenfold the number of connections. The next slide shows the scalability of the throughput. Of course, it's the most important metrics because you send many packets through a single connection, and the scalability is, again, I think, acceptable. So there's some degradation, but not much, and it is stable. And the other side of connection setup is connection tear down. Every connection which is set up, then it has to be teared down. So it was a different kind of measurement because we cannot delete the connections one by one easily. So some connections were loaded into the connection tracking table, and then the entire table was deleted. And to make the measurement a bit more precise, the deletion time of the empty table was subtracted. And of course, thus the communication latency was also subtracted. And the net deletion time was divided by the number of connections. And it shows that more or less stable value. So this is the addition for today. And in this paper, you can find all the details. And it was about OpenBSD, what I was talking about, but there are some other measurements also described here. And my question is that, is these kind of results useful for you, the network operators? Do you consider this draft useful, and would you like to perhaps adapt it? Thank you.
So Tobias Siebig, not strictly an operator employed at the MPI as a researcher, but speaking for myself. And as myself, I've been running AS59645, which has been using OpenBSD as its core routers for quite some time. But I had to have the realization that OpenBSD is just not the fastest when it comes to processing packets, which is kind of security related, right? They do many funny things. So looking at the work you just presented, I am wondering whether that what was measured was OpenBSD's packet processing performance in general, or, as the draft says, the scalability of transition technologies.
It was just the performance of the stateful NAT64 implementation. That paper contains some IP version 4, version 6 packet forwarding performance also, but what I was talking about is just the performance of stateful NAT64.
Yeah, in OpenBSD.
Yes, yes, OpenBSD PF.
Well, Lorenzo, I think benchmarks are always useful. So, I mean, thank you for that. In terms of should this be adopted as a working group item? I mean, I would think that the goal of adopting something as a working group item is to get to an RFC, right? And an RFC is kind of not a useful mechanism, I think, for publishing benchmark results because it can only be published once. It can never be updated, right? And this stuff is going to change, every few months when we do something. So maybe publishing the methodology, yes, but or the source code. But again, I think that's sort of maybe better on GitHub, right? So, not saying that the work is not useful. I'm just saying, do you really want to go through working group and then publish an RFC, which after a few months is going to be out of date?
Thank you.
Yeah. Quickly joining in on that. So the question would be, maybe it would be more something for the IETF, which also publishes RFCs, which are measuring things.
Well, as for the methodology, how to measure the scalability and performance of stateful NAT64 technologies it belongs to the benchmarking working group, and there's an RFC which will be working group last call maybe next week. So this is the methodology how I measure. I thought that the results may be interesting for this group, but if not, then I understand it.
Okay, if no more questions, let's move on to Tim's presentation. Thank you, Gab.
Okay, I'm here to talk about V6 CE routers, so home gateways. I'm going to hit two different drafts actually in this. One of them I presented on before. One of them is a newer situation I'm going to talk about. Okay, so two drafts, prefix delegation on the LAN. This has been an ongoing thing, and then I'm going to talk a little bit at the end about an update to 7084. It's not liking me anymore. Sorry. There. Okay, so for this draft, originally, here's the deal. We have a lot of home gateways that greatly ask for giant prefixes. It works great. It goes to the gateway, and then it never gives out any more of the prefixes. So the problem we're trying to solve here is have home gateways give out prefixes on the LAN interface by enabling PD. And almost through any mechanism I'll take at the moment, because this has reached the point of ridiculousness. We're wasting a bunch of addresses in the home. They're not going anywhere. They're just sitting on the edge. So the original idea I had for this draft was to do it in a flat format. I got some pushback in particular because the e-router spec at Cable Labs has hierarchical. So I updated the draft this go around to allow for both. My main goal here is we just need to get prefix delegation turned on in the LAN and have these devices giving out prefixes. They're both documented there. Now in it, they can work. We've run some testing that they'll work fine in conjunction. You can waste addresses if you're doing hierarchical. I prefer flat, but it's in the e-router spec, and I don't want to get into a war about that part of it. I really just want prefix delegation to get turned on the LANs. So those are the changes I made. The changes in the last draft, I haven't gotten any comments yet. I would love some, were that as I broke them out and said, okay, prefix delegation, you must do that. Hierarchical, I added those. I took them directly from the e-router spec. And then the flats are still the same, where we turn the other routers in the home into relays to route it up to the router that has a prefix bigger than /64. Yeah, I mean, my main goal here is there's other technologies that can use prefixes in the house, in the home, in any network, and we want to enable them. Ted, you want to go now?
Well, it doesn't have to be now, but I had a question about the e-router spec.
Yeah.
Does the e-router spec say that the thing that's trying to acquire the prefix says what amount of what width it wants, or does it just?
They have two options. They have flavor width and flavor depth.
Okay.
And they specify that, yes, they absolutely. If you read my draft, I stole their words and where the bits are set. So
Okay.
they have rules about all of that.
Yeah, I mean, the problem with doing that is that I think it's a bad idea. And so explaining how to do a bad idea seems like a bad thing. If they can do it, even if we don't we could certainly say that the DHCP PD server, if it's asked to do what this document tells it to do, does the appropriate delegation that's been requested. But I think any additional information about why that would be done is going to just encourage people to do the wrong thing because they don't really understand, and it's going to sound like it's better to ask for more.
Yeah, fair feedback. I think the move here might be to just say, hey, turn on prefix delegation and you should do the flat model, was going to be my backup proposal if people really hated me putting this in here, which it sounds like you're in that category.
Well, no, I totally appreciate you. I do not hate you at all.
Well, that's okay. I get that. Okay, so I'll take another crack at that. I think there's a little bit of truth in that I don't think, and I think Ulay is going to talk about this in a minute in his draft about the flat model. I think that's where we seem to be drifting. So I'd be okay being silent on how to do that and just let the Cable Labs guys do their thing. Okay, come on, Lorenzo.
I'd say do whatever you can do to get this document published. Sometimes the best way is to delete everything that people disagree with and move on. I don't know, do whatever it is that you can do.
I mean, I definitely debated writing the draft and just being like enable PD, and I don't have strong feelings about it.
We haven't even adopted this yet?
No.
What are we doing?
Okay.
Okay. Okay, sorry.
Yeah, I'll send another note. Yes, I think we should adopt this and sort this out.
So request to the chairs, please do not say that because the draft has changed, we need to wait for people to read it. Please adopt now, yesterday. Please. Yeah. Thank you.
Okay, we'll still take it to the mailing list.
Yeah, okay.
We
I look
can make
forward
a
to it.
quicker decision, but
I'm excited. All right, this is the other thing I was gonna hit on. Okay, I've got time. All right, so 7084 biz. So I couldn't believe this. 7084 is 10 years old now. And so where we're at is it's got some old text in it. And occasionally people run into issues. There's RFC update issues. There's a lot of text in there about 84. 8415 DHCP code's been cleaned up. So we should clean it up. There's a couple of other things we've done since then. And so this is I sent it to the list. It's independent right now, but I would like the working group to think about working on 7084 biz and making an update. I will say I want this to be, I'm gonna caution the group, I want this to be scoped in the sense that I don't wanna try to solve all of V6 edge router issues. So the scope here is we want to remove the transaction technologies that were listed in there. I did have a customer last week come to me and say they needed to implement 6RD because it was in 7084, which is my worst nightmare. So I was like, please don't do that. We need to take this text out and tell people to go read RFC 8585 and just 7084 doesn't talk about transition technologies. Someone wrote a very nice, group of people wrote a very nice RFC about that, go read it. The other thing that's come up, and this has come up with a lot of attacks, we had a should for ingress filtering. We should fix it, S2 in there. We should make it a must so that get rid of all those spoofing attacks. That's security. And the other security issue we've had is the EUI64 on the WAN interface. So whoops, this finally came to bite us. There was a paper about this. We should just tell people not to do it on their WAN interfaces. And the only other change that I think we should make is this document was originally informational. I think it probably should be best practices, but I'm sure there are more things that people are going to want to take on in 7084, but this was what me and the authors came up with. Go ahead, Lorenzo.
I think you should make another change. I think you should require PD on the LAN.
You just
no. I mean,
I could go.
That's what you're trying to do with the other document, right?
I was
people
hoping,
might read this one.
My hope was that document would get adopted and get done while if there were other things we had to sort out. I'm okay if we want to tank PD on the LAN and just roll it into this too. I don't have super strong feelings.
No. I think you should require that other document be implemented. That's what I'm saying.
Okay.
I actually had a question on the other one. It's like, you said like we should probably say should or must do this.
Yeah.
I'm wondering if we need like separate shoulds versus musts for like the relays and the sort of Apex thing. I'm sort of
Yeah, I think we can play with that. I'm on board with all of that. I think we can do that as part of this. I think there are a couple of other things coming down the pipe we're gonna have to talk about for 7084. But I guess what I'm asking is I'm hoping the working group is up for updating this document after 10 years.
That's an important. I mean, as long as we don't get into some /64 debate about it. I mean, maybe. One point actually for the EUI on EUI64 and WAN. One thing that I think is front of mind for definitely Android, probably other mobile OS developers is, can I somehow get a persistent identifier for the network I'm on and use that as a proxy for location information? So if you could randomize the LAN, either MAC address and or EUI64 or whatever, right? That, because we block access to ProcNet ARP and we do all of this stuff. But if I do traceroute to the LAN gateway and I get an ICMP unreachable from a link local address that never changes, that's a persistent identifier that I can use to identify location.
Yes. You're totally right. We should do it on both sides. I agree.
okay, Tom, you want to make a quick comment?
Thank you. Yeah, Tom Hill from BT. I was just looking at this piece about removing transition text, and I had to quickly Google those RFC references because I didn't know them off the top of my head. But I think it would be beneficial to be a little bit more prescriptive about including transition technologies rather than making references to that they exist.
Come on. So here's the deal. Here's the deal. Like, I've never seen a CP do them all, right? And then the idea that we're going to pick one is not my idea of fun and the thing I wanted to avoid. I know what you're saying. I think we could say you should do some of the transition mechanisms in there, but I don't know, I cannot see us running around this mulberry bush again, trying to figure out which ones we want to suggest, prefer, is my fear here.
I do appreciate that conundrum.
Yeah.
Completely. However, when sourcing CPE, one does tend to fall into an argument that involves why don't you support this a transition technology?
Yeah, but I can't get any of you operators to agree on which ones to deploy is the problem here.
We're getting better at that.
Not fair.
We are getting better at that.
I'm not totally against this. I'm just worried that if we open this can of worms, we're going to be running around in circles for
the tool
months.
for that is not an RFC, it's an RFP. This was written for off-the-shelf stuff, right?
Okay.
Our RFPs are so singular for an individual company. That's the,
I hear you.
It's a tough problem to solve.
Okay.
Appreciate it.
Wu Lei.
Hello, so my name is Ole Trön. I'm going to talk about the counterpart to Tim's proposal. So the purpose of this talk, it's triggered by the PD per device draft that explicitly specifies the network behavior. And so the question to this working group is, do we need a corresponding host requirements document for doing network extensions? And revision 00 is largely a placeholder draft. Let's figure out what we should put into it if we decide that this is a document that we need or not. So the purpose of PD per device is to essentially give the same behavior if you do PD to a host as you have if that host is connected to a network doing normal Slack. It's basically limited to a single /64, and if you want to extend that, you do that with, you know, a bridge or some flavor of that. But it leaves the door open for further network extensions and extending the router asking for a larger prefix with, you know, flatter hierarchical PD. The document doesn't, at least if it's purely doing PD to the host, it has to do something regarding source address selection, because it would have, you know, an upstream interface which is essentially unnumbered. It only has a linked local address, so it had to be able to pick, you know, a global source address from the interface that you assign the PD to. But apart from that, there isn't very much change. But at least we have, you know, requirements like that. So what this draft does in its current version is to provide the network extensions regardless of address assignment policy on the northbound link. So very much, you know, written from the perspective of I having my laptop with a set of VMs or VM-like processes on it that needs addresses, and it need to be able to do those extensions if I'm sitting in a coffee shop, or if I'm sitting on the Cisco Enterprise Network, or if I'm sitting here at the IETF. Cisco IT is not happy about, they will not let me do network extensions, but I want to do network extensions, and I can, so I'm going to. But at some point, it's turtles all the way down, right? This is essentially a set of Tim's CE routers, and you could stack them as deep as you want to. And at some point, you're going to run out of /64s, right? In the current PD per device draft, you run out as soon as you want 2 rooted links. So the draft suggests an ordered list of mechanisms to try, both northbound, and it suggests an ordered list of mechanisms to provide addresses southbound. But I'm still upset about this, by the way, that it's turtles all the way down. I wanted a rooted fabric, you know, what a normal, you know, OSPF network gives you or HNCP gives you. But what we're left with now is every man for himself. The benefit of it is that it's permissionless. Largely, it does not need any or very little cooperation from the northbound network. But it's what we have, right? So the types of northbound networks, and this is probably not entirely complete, but it's, you know, you can connect to a Slack network or Slack link, but it runs some sort of security limiting you to one MAC address. So you can't borrow more addresses from that /64. You could be connected to a link doing just the IPv6 address assignment, or you can connect to one that does both Slack and DHCP, or you could be one that supports PD, but you know, PD of whatever prefix length you get to, and you could connect to one which does support PD, but you know, hierarchical and flat will force the extending router to behave somewhat differently, depending. And of course, you can also connect a link that isn't Ethernet, if anyone is old enough to remember those, where you can't do bridging. And the mechanisms you have available to you northbound, if you want to extend the network, is, well, a PD client, if you can, right? That would be your preferred choice. Then you would get proper global addresses, and you would have end-to-end reachability. You can try various flavors of, you know, bridging combined with ND proxies and RA proxies to borrow addresses on your North Stream link southbound. If you can't do that, you end up in sort of this similar approaches of, you know, NAT66, for example. If you have, that requires you to have many addresses available northbound as well. Even worse, if you only have a single address, you're stuck with, you know, mechanisms like V4 where you have to do NAT66. Or you could also, I mean, a /64, if you got that with, in some fashion with PD, you know, a /64 is enough to number every network on the planet, right? We have infinite amounts of addresses if you use them wisely. So it would be possible to run a rooted fabric, you know, southbound as well. But of course, if the northbound supported, you know, HNCP, then you should do that. But that's kind of a shot in the dark now. And similarly for, you know, for addressing, since this is, you know, you basically sort of replicate these mechanisms southbound. So if you have enough addresses, you could give PD southbound as well, of course. But if not, if you have a single /64, you could do that for Slack and do bridging and the proxying, or if you have less than a /64, you have to do the IPv6 address assignment. Or of course, if for VMs and stuff, you don't need any of these mechanisms. You could do essentially manual configuration, which means, you know, configuration by software, right? And you can also increase the size of your address space by, you know, combinations of ULA and NAT66. But, you know, hopefully you will have a 64 for all the links you need, and then at least you can get to proper normal addressing. So there will be, you know, the people who are extending will not be, you know, second-rate citizens compared to the ones that are connected directly to the northbound link. That's basically it. So this is a very rough sort of placeholder for what I was thinking. Is the working group interested in started work on this? It's a long way from being, you know, asking anything about adoption or anything, but at least if anyone is interested in joining up, we could try to get something done for the next IETF. Jen.
Yes, thank you. As a co-author of PD draft, yeah, I do think, yeah, we need to talk about what host does. I'm still horrified to see this three-letter word called starts with N on your slides. But yeah, well, let's talk about what could be done. My only concern, I'm still not sure we can solve the generic problem, right? Unlimited number of layers for unlimited number of interfaces. So I don't know, maybe we don't want to boil the ocean and we want to define what we definitely want to support and everything else is like best effort. But we'll definitely talk more this week, yeah.
I'm sure we've all seen that picture with someone stacking 30 NAT44s after each other, right? You run out of turtles at some point, but it works for some definition of works. And we can at least do that.
Lorenzo Colletti, let me start off by saying I share your interest with network extensions because it is, I'm just going to keep repeating this until I'm dead. It is a question of parity with IPv4, okay? You can do this. Doesn't matter what Cisco IT thinks, you can do this, okay? We need to make it work in IPv6, and preferably without doing the NAT that like makes it harder for app developers. So let's start off with that. As for host behavior, you're correct about the source address selection thing. Our plan for writing that up was to wait for 64PD to get past working group last call, and then that text is in right now in the 6-man doc that we're going to present tomorrow. So that is also an alternative place to do some host requirement stuff if you want. That was specific to the P flag, which it communicates whether the prefix is available or not, but we could collaborate if you want. So that's a place to put this. We could do it in 6 months. I don't know. For the turtles all the way down thing, I think the problem is that there are two types of turtles. They're your turtles and they're turtles from the upstream, right? And we need to find a way where the upstream turtle, which says you need an extra $5 for an extra IPv6 address, is not going to constrain the behavior that we can do down at sort of in our area. So I guess what I'm trying to say is what 64PD is trying to achieve is basically at least get the address space that you need to extend. Because in theory, once you have a 64, you could extend indefinitely. It's just that you need to build a protocol somehow to do it. You could do Babel on 128s, whatever, I don't know. You could do Babel with 128s. You could like basically set up a link local mesh and just do Babel with 128s. Why not, right? So I think that's something where we need to really separate it out. And the final thing is, yes, please let's consider end-to-end. One thing that I already said, I think on the list was, we won't be able to separate the northbound versus southbound assignment policies if we want to maintain end-to-end. Because maintaining end-to-end means that the northbound needs to give you exactly at least enough addresses to do southbound. And if you can't do that, for example, you can't say, oh, northbound is DHCP6 and southbound is whatever, NPT66, because that doesn't work, right? Because NPT66 translates the whole prefix. Anyway, just...
I fully agree with you, Lorenzo. And I think a consequence of us failing to do network extension is that we end up with this cascading, which have these properties. If we can do better, oh yes.
What about Babel with 128s? I don't know, would it work? Julius, would it work? I can change the hosts. Tommy can change the hosts. No, that's not hard. Ted can change the hosts.
So I think we have to take those ideas to the bar, but yes, I would be very willing to do so.
For your question here, I definitely we should work on this, because if we don't, this is gonna go poorly. So that would be I'm willing to help in any way, but people are gonna make some really, and already are making some really creative decisions with this, and I think we're just gonna make it worse if we don't give people a little bit more guidance than what we currently have.
Philip Diesel. As someone who is currently trying to push an organization with a lot of developers into the IPv6 land, I definitely say it would solve a lot of problems having these kind of network extensions, especially if you like in a corporate environment where people want to have control. Just being able to say, okay, you can have your VMs, you can have them accessible, but we are able, from a security standpoint, to pinpoint, okay, it was a device on that kind, and even being able probably later to pinpoint it was that VM, it was that container that had caused an issue, makes the whole debate much easier from a security point of view than saying, oh, it was something behind that NAT, we forbid you the NAT, you're the evildoer. So I'm really, really in charge of that idea.
Cool. I'll co-author you in immediately.
Hello, Martin Hunyang here. I would, first of all, I would like to say that, yeah, we need defined behavior of the host. And it's something I'm deeply missing in the PD draft. And one thing is that the device should be able to say when it wants to do extension of the network, and some kind of signaling. Yeah, because now we do have this kind of signaling with the routers. Routers do PD, hosts do not. Now with a host PD, we are in the situation when we don't know if it is a host or if it's a router. So this is the main thing, mostly for a PD draft. But yeah, not every network should be extended. Cisco corporate network would probably have the same idea. And the thing which is quite important to have clearly defined host behavior. So yeah, we need some document like this.
Thank you. And coming from a routing vendor, I really like the idea of making every node, V6 node, a router instead of get away with hosts. So.
Thank you.
Markus Stenberg. I had just one point that from my point of view, the interesting question is actually if I have a couple of hundred containers on a node, is it actually a node or a router? Because I don't actually even care about the subnetworks as such nowadays anymore, but I'm very interested in having addressable containers. And the problem with current standards and especially the cloud provider implementations is that usually if you get IPv6, you get /128 and you deal with that. And that's basically wrong. So I would really love to have some sort of specification that, you know, if you are a node, you are allowed to get some IPv6 addresses, even if it's just less than a /64. But this is just my personal problem and maybe not everybody else's.
But I think Lorenz's document is very clear on getting you more than a single one. Yeah. Thank you.
Okay. Thank you, Ule. Nanili.
Actually, we'll just pass this around, mostly Vanessa. Okay, so hi guys, this is part of our deployment at Enterprise series. And so actually Vanessa and Kavya are going to take over. So this is a student-led deployment of IPv6 at the National Institute of Technology in Karnataka, which is in India. And Vanessa and Kavya are final year undergraduates at the university. And they started, I believe, last year doing this as third year undergraduates. And there's a team of undergraduates who is doing this. So let me turn it over to Vanessa.
Hi, everyone. Just a brief outline of the presentation. So I'll be covering the project overview, which is our team plan of action, the project status, and also the next steps for our project. Briefly introducing the team, we have a team of faculty members, students and network engineers, including Kavya and myself, and also support from IESOC, as well as an advisory team. So our plan of action was initially setting up a test bed at our college campus to test the basic functionality of IPv6. We wanted to gain more insights into DDI and IPv6 functionality, and also migrating our network services to IPv6, of which currently IPAM has been migrated. We also want to enable dual stack functionality and update the web services and applications at NITK. So we have some in-house applications, namely Iris, which we will talk about later. It is a mobile and web application used by more than 7,000 students on a day-to-day basis. And currently that has been migrated to IPv6. Just to give a bit of context into the size of our campus network. We have more than 45,000 terminals connected to the internet, and with a new campus coming up, the number is expected to rise significantly. We also have more than 350 switches, 1,200 indoor and outdoor Wi-Fi access points, and a dedicated data center as well at our Suratkal campus. So we leased our IPv6 address block from Nixie and obtained internet services from BSNL, which is the local ISP. We've set up an ROA, and now we've advertised our IPv6 block, which is 2400-4F20/36. So I'll briefly go over the testbed setup at our campus. So we've designed it in such a way to isolate it from the computer science department subnet, which is where the testbed itself is located. We have 5 host machines, 5 test machines, of which machines 2 to 5 are on native VLANs with IPv6 addresses. And on machine 1, we have an OpenSense router connecting all of these machines. We've also set up a GIF tunnel from machine 1 to the NITK OpenSense router to have IPv6 connectivity over IPv4. So currently our testbed has only IPv6 addresses. We plan to also include IPv4 connectivity by DMZ forwarding packets to the OpenSense router. Some of the things that we plan on testing out at our testbed is extensively testing out DDI. So for DNS, the different configurations, and also checking out how RDNS would work. For DHCP, we have tested the different router modes, managed, unmanaged, and also seeing the prefix allocation and address allocation mechanisms. We also want to test our L2 switch, which our intermediate switch, and test neighbor discovery on it because this has to be deployed in the production environment in our main core switch. And lastly, we would want to test firewall rules on our NITK OpenSense router, for example, for ICMPv6 as well.
Okay. Yeah. So these are pictures from our IPv6 deployment workshop at NITK, which we had conducted in March of this year. We had over 90 participants from our college as well as surrounding colleges come in. Nalini, Dhruv, and Priyanka Sinha had also joined us to give us talks. And some of our projects also had workshops related to them. Yeah, so coming to the status of migration of applications to IPv6, as Vanessa mentioned, we have IRIS, which is our learning management system, already migrated to IPv6. IRIS is a system that has automated over 40 plus processes at NITK, and it's used by over 7,000 students and 600 staff every day. As for the integrated applications on IRIS, such as Moodle, Big Blue Button, Autolab, and Sentry, the IPv6 support is still ongoing. Let's also look at some statistics from IRIS. These are stats seen over a period of 40 days. This shows the ISP distribution of IPv6 hits. The blue section, which is the major part, is from Reliance Jio, followed by Airtel, which is about 56% and 23% respectively. This graph here shows the client count of the number of hits coming in from IPv4 versus IPv6. So observations we've made are that Windows sees a significantly higher number of IPv4 hits compared to IPv6, while on Android and Linux, we see a higher client count of IPv6 compared to IPv4. And the clicker's not working. Oh, sorry. Yeah. Like I mentioned, the number of hits on Windows is greater for IPv4, with about 1.8 million hits compared to 600,000 hits on IPv6. And there are a couple of questions that we want to try and answer in our future analysis, which is the first question here is what kind of network the end users are on? Is it IPv4 only, or are they on dual stack setups? And another question that we have is whether Happy Eyeballs plays a role in the preference for IPv4 on Windows, and that's something we also want to check. And alongside that, we also want to look at the role of DNS, if any. Coming to the status of our migration of VPNs, NITK uses two VPNs. Our L2 VPN is OpenVPN, and on L3 we have WireGuard. Both of these are migrated to IPv6. The next upcoming work would be to evaluate performance and test packet losses, latency, and other parameters for VPNs on v4 versus on v6. For the upcoming months, we have a plan to wrap up our testbed experiments, which Vanessa outlined, migrate our integrated services of IRIS to IPv6, and also prepare a thorough documentation of our migration process, which would potentially help other enterprises as well. So we plan to, we're currently documenting migration of IRIS, which is our learning management system, our migration of VPN services, and our testbed experiments. The funding for this project is provided by ICEF Asia, and we're working in as part of COSH, which is our Center for Open Source and Hardware at NITK. We'll also be providing a technical and financial report to them as well. Thank you.
Tommy Jensen, Microsoft. Hi, you want to come talk to me afterward? I think we could probably exchange some fun information. Anyway, thank you for sharing the research. This looks super interesting. Love seeing university work coming into the IETF.
Thank you.
Sipeng Xiao, I have also a question. You know, when you have this IPv6 deployment, I'm always very interested to find out what traffic percentage level, also the IPv6 packet loss rate. So in your future work, if you can do some measurement on that, I think that it would be great. I think that just now I saw from one of the slides that seems like the Windows, you know, is using more IPv4. I think that maybe I think this, you know, Jensen is also very interested. I would love to hear an update on this. Thank you.
Hi, David Skenazy, Happy Eyeballs enthusiast. I just wanted to say thank you so much for not only doing this research, but also for bringing it to the IETF. This is very helpful to us. And definitely take advantage of being here to talk to people like Tommy and getting to see if it's his fault, he can fix it. And if it's not, we should find out whose fault it is so they can fix it. So thank you so much, and please keep doing this.
Thank you.
Johnny from Huawei. Again, thank you. And welcome to IETF. I would like to see more students to visit IETF. Thank you.
Thank you.
I don't appear to have a blob on the thing, but anyway, Greg Chul's ISC, we write DNS and DHCP servers. So if you have some issue, I'm curious to know what DDI you use. And if you want to explore DNS and DHCP further, come talk to us.
Sure, we'll do that. Thank you.
Thank you. Thank you. And we move on to Jane's presentation.
One quick thing, we have also done improvements and modifications to neighbor discovery. We'll talk about that in the side meeting. We've changed free router. Kavya and Vanessa will again talk there. So please come.
Hello. This is part one of a presentation about impossible things, unicorns, and turning off IPv4 in enterprise network. So where I structure it, I'll give you an overview of what we've done. It's 25 slides per second. And on Thursday, we'll talk about the most interesting part for any engineers, about what exactly went wrong and how wrong was it, right? So let's just talk about general things. First of all, why any sensible human being will do that? First of all, because, surprise, surprise, dual stack does not solve the main problem, the main reason to deploy IPv6. It does not help you to conserve address space. If you're doing dual stack, you still assign v4 and v6, and you still need IPv4 addresses, and we actually run out of private address space. And also, I hate operating dual stack because it's operational nightmare, right? You have two planes, and troubleshooting is hard. And also, we have people developing v6 stuff, and they really wanted to use v6. So we decided, let's get rid of IPv4. Well, not get rid, let's redistribute it to places when we need it. So what kind of network do we have? Like enterprise network, a lot of sites. We do not use DHCP v6 for address assignment. We use Slack to give addresses to devices. To give access to IPv4 only destinations in the internet, we use NAT64, and if host needs it, DNS64. We do in NAT64 in every side edge. And actually, our router advertisements basically give hosts DNS64 addresses, and it also gives host Pref64. So we, strictly speaking, would like to get rid of DNS64 eventually. It's currently only for like legacy host support, because if you have Pref64 and hosts can do local synthesis, DNS64 is kind of optional. So we have DHCP v4, obviously. It's centralized, and it's important. So we have some data centers which run DHCP v4 addresses, and I'll explain in a second why I'm talking about the legacy protocol here. And for wired hosts, we use .1x, and we assign a lot of different VLANs to hosts based on .1x authentication results. And again, on Thursday, I'll explain why it's important. So, quick recap. I think it was 2020, 3 years ago, when I came here virtually and told how we did our proof of concept. Well, we took our biggest Wi-Fi segment, which is a guest one, and turned off IPv4 there. The reason was because guest Wi-Fi probably has largest number of mobile devices which are supposed to work very well on v6 only. And obviously there was some use cases for v4, so we created a dedicated SSID which had IPv4 enabled. And we also did the same with a wired guest network, because we knew we will need to put some devices where we have a business reason for v4. The great thing about the project was that we proved that it could be done, and we reclaimed a lot of address space which helped us to survive until now. And there is a link of presentation I did at RIPE, and I think somewhere at IETF archive, there is a video for my previous talk. So what we learned 3 years ago is that, yes, it can be done, but having a dedicated fallback network segment is a horrible idea, because when users see multiple SSIDs, they just, I don't know, how many people here know which SSIDs they're connected to? Nobody cares, right? You just pick up one which works, and that's it, which means practically that a lot of devices which could have been v6 only were sitting on dual stack SSID, competing with devices which really needed v4, for example, like MacBook's internet recovery, and also other business critical applications like Steam and Spotify. And also it gives very low visibility of issues, because if IPv6 only SSID does not work, user just moves to dual stack and never come back to me and tell me what's wrong. Also scalability, Wi-Fi team hates having multiple SSIDs. And on wired network, I just could not do this, because I have a lot of VLANs. If I start doubling them, it will be like operational nightmare. And again, operational complexity, multiple SSID, everyone is confused. So 3 years ago, we realized we need something better. What we really needed, what I wanted, is what I called IPv6 mostly network. When I do not create separate segment, legacy devices behave as usual, and devices which could be v6 only could signal IPv6 only capability. And if the network is willing to support v6 only devices, they negotiate that and device becomes IPv6 only, right? So I don't need to change anything on the network, same number of VNALs and same number of SSIDs. So I talked to people here and we came up with RFC to use DHCP v4 to turn IPv4 off. Because I remember it was a discussion about using array flag for this and people were against it and they were right? It was security concerns. But DHCP v4 is the protocol which almost every enterprise deploy. They control it, so it's the best mechanism to turn v4 off. And just to remind people who were not following DHC working group, it works very simple, in a very simple way. Legacy devices works as before. If device is v6 capable, it includes option 108 request in DHCP discovery. And all legacy servers, all dual stack networks, just do whatever they've been doing. But if that device connects to my network, I want to migrate to v6 mostly, my DHCP server will be, oh yeah, you want to be v6 only? Great. I'm not gonna give you IPv4 address. Please shut up for 5 minutes or 10 minutes, whatever, it's a parameter, right? So as a result, I can incrementally move devices on a given network to v6 only mode without touching the legacy stuff. Beautiful, right? So what we've done, actually, we looked at all our offices and decided to enable this option 108 for every single user-facing VLAN, wireless, wired, including that fallback guest SSID, which we created 3 years ago. Because, yeah, as I said, a lot of devices which were sitting there did not actually need IPv4. So devices in scope, obviously, devices in scope are devices which can be IPv6 only. What does it mean practically? It means they have 464X LAT and they can send option 108. Combination of two things, which is Android phones and Apple devices. Thank you, Apple, very much. So all of them are just doing it unconditionally all the time. Thank you, Lorenzo, yes. So unconditionally. So as long as I enable option 108 on a given DHCP enabled network, those devices become v6 only right away. We also have a capability for Linux and Chrome OS devices to opt in. So users can go and manually turn on the flag. Benefit of opt-in, obviously, is that those devices do not have 464X LAT for everything. So I wanted engineers who are interested to try this and come back to me and tell me what's wrong and what we can fix. So rollout schedule, I did a pilot for like 3 months in Sydney and a couple of other locations. Then we extended it to 5 other big offices. And then we say, okay, we are ready. We did not find anything which looks like a showstopper for us. So we can stop the bleeding and start deploying new stuff that way. And after that, we started doing incremental rollout, which for me, incremental rollout means I'm taking the whole IPv4 enabled DHCP segments, split them in percentage. We are currently at 90%. I really wanted to stand here with 100% being like green, but my travel schedule, it will be done in December. Before end of the year, we're going to enable option 108 for like every segment, which means again, all macOS devices, all phones will be v6 only. So results, you know what? I can't believe it. It was surprisingly good. I usually like skeptical and suspect things will get broken. Yeah, we found some issues, don't get me wrong, but it was no showstoppers. It was a few interesting issues, few cosmetic issues. Everything I reported to Apple was properly fixed. Thank you very much again. I really appreciate it. It was amazing. Few cosmetic issues may stand, but nothing which like makes user unhappy, right? DHCP utilization, average. Well, there are sites which have more Microsoft Windows or Chrome OS, but average utilization drops like by 3-4 times, which allows us, we're doing reclaiming now, it probably expected amount of address space we're going to reclaim going to be like hundreds of thousands. Just a graph. large campus network, internal like corporate Wi-Fi /19 initially, and see it's like 40% utilization normally, so I cannot downsize it, right? Because if I make it /20, it will be 80% utilization, which is above the threshold we're using for increasing the subnet size. I enabled option 108. Well, it's not really typical network. Normally it's like 4 times. It's not like 7 times drop. But yeah, we downsize it to /22. One given segment gave me like 7,000 addresses back. Great. I am happy. Everyone is happy. Management is happy. Nobody complaining. So, lessons learned. It will be more of them on Thursday, but we keep talking here, right? How can we get more networks deploy IPv6? How can we convince them? I'm sorry, we cannot. The only way they're gonna do this is when they realize, oh my God, I'm running out of space. I'm trying to deploy a new office and my automation fails because there is no addresses in the pool. That will be the driver, because I've been doing this for 10 years in corporate part. And we really started doing something when we realized we're in danger. So you can get much further with a good word and a gun in terms of V6 deployment than just with a presentation itself. So, second, lessons learned. Again, technical stuff will be on Thursday, but I had been thinking, yeah, we have IPv6 everywhere. We know how to do this. It works. Apparently, it mostly works. And that mostly is quite disappointing because you cannot really detect it until you turn IPv4 off. Like one example, I'm going to talk again on Thursday more about that. Your workstation works fine most of the time, but when you open your laptop, it might take between 5 seconds or maybe 5 minutes to get your DNS back. And like nobody complained until I turned V4 off. And when I did, we found that in some cases that happens. And again, it's a race condition. You would never get it like without getting users on V6 only network, right? Because users do not report issues because of happy eyeballs. Yes, happy eyeballs are great, but when you turn V4 off, you find out things. Even if, I was absolutely sure I'm ready, right? My laptop was sitting on V6 only network for 3 years, and I decided, yeah, we're ready to go. I can go and move all MacBooks to V6 only. And then I spent last 3 months dealing with very interesting cases. Again, no dramas, but very interesting cases about like, this less than 1% of the time, it might not work as well as before. Right? So yeah, as I say, I support happy eyeballs, but don't get into this false sense of security. If you're running dual stack, you actually do not know about what's really going on in the network. Yeah, I think I have 2 minutes. My favorite discovery, that's why this working group got so many emails recently. So I had a lot of devices which look like a host, behave like a host. I was quite sure it's a host until I turn off IPv4's upstream interface, and suddenly a lot of devices in every single office stopped working. And if you take a screwdriver and open it, oh, there is a router inside and a couple of tablets connected to it, and all that stuff was extending the network behind it using NAT. And now it doesn't have NAT, it doesn't have IPv4 on upstream interface, and device is very, very unhappy, right? So, yes, I guess most of the people in the room noticed what we are trying to do with this, right? We're trying to let it extend the network legitimately. But I'm not going to talk about that anymore, right? We have 1 minute and we'll need another 3 hours for that. So, summary of non-so-technical lessons learned, when technical, okay. The maximum number of complaints our support got was about we had a lot of laptops with IPv6 disabled. Because for many, many years, every time something did not work, support people were like, I tried to disable IPv6. Oh, helped. Great, ticket closed. Nobody ever was thinking about how we're going to re-enable it back. So we had to deploy some automation to go across all fleet of laptops and re-enable IPv6 back so people can connect to corporate Wi-Fi. Extension headers. Great, we need them. Surprise, surprise. Because if you use NAT64, your v6 packet is always 20 bytes larger than IPv4. So even if you get 1500 packet from IPv4 internet, when you translate it, it might get slightly bigger that you can send out. So it will create fragmentation header inside your network infrastructure. So I think it's quite safe to allow. Also, ESP extension header, which is actively used by Wi-Fi calling, because it's IPsec and normal VPNs, needs to be permitted, and it's also quite often get fragmented because, again, it might be UDP. So your TCP clamping doesn't help. And again, come on Thursday, it will be a very interesting discussion about what happens when the client starts moving between networks and how default address selection rule 5.5 is critical there. So yes, it's a teaser. So this project resulted in at least 3 drafts. One of them we discussed extensively, and I just submitted 2 more drafts. One is about how in general a node, router, or a host shall enable 464xLAT. And another one is going to address this client mobility issue, which I'm not covering on this set of slides, but I'll be talking about on Thursday. So next step, so stay tuned for next year presentation. Chrome OS supports option 108. You can enable it. So if you're using Chrome OS, Chromebooks, try this on this network. And yeah, it's what I'm going to do next year. Questions?
Yeah, Lorenzo Coliti, you forgot to mention the many RFCs that you had to write for this to work as well, such as Pref64, option 108, you know, like all of the stuff.
Yeah, we had to write, thank you.
Yeah,
but it's been a preparation work, right? This is, I'm trying to explain why this group is getting so many emails, because I know some area directors complained.
So I mean, I'm actually co-author on some of these, so I probably shouldn't say this, but this is actually, I mean, I never believed that this would happen so quickly, right? We've been talking about IPv6 certainly for a while, but like not only actually doing this, and you're not the first, right? Facebook, Google, in prod, they did it, but doing it on a network where you can't push config change to the host, that's actually a big challenge. And so we had to use network protocols, hard stuff to do all of this, right? So I think kudos for that. I mean, and given that this is like kind of non-obvious, all of this stuff is actually quite new, like Pref64 new, option 108 is new, all of this stuff. And are you going to write up a draft saying like, here's how we did it? You can't say here's how to do it, because people will say, but you're not using DHIPv6, so they won't use it. But you could say, here's how you can do it. Right? So that's something,
yes.
Writing it up would be useful.
Yes, to be honest, I did not, my manager told me that we need to write something. I wanted to get to 100%. I wanted to get to 100% on that and maybe on Chrome OS, but we'll see. And yeah, I'm definitely not before December. I hate reporting stuff which I have not done. But yes, I will definitely share this. Yeah.
And if there's anyone else in the room who runs an enterprise network and wants to try this and doesn't require DHIPv6, well, let us know how it goes. Usually you can't do CLAT with DHIPv6. It doesn't work, right? So there are things where anyway, so if there's anyone who wants to try this, let us know and maybe become a co-author, because I think, you know, this can be done today. It's slightly tricky, but after it's written down, I mean, I think Jen's done all the hard work, so, or most of it, so.
We'll find out.
Andrei Salatka, as a person behind RIPE meeting network, I can tell you that, yeah, we implemented already 2 RIPE meetings in the past, and it is running, and it's going to be running also in the network that is going to happen in the next RIPE meeting. What we see is basically the same thing. So it's like, yeah, let's say 70%-ish of devices are running v6 only in the network. What we see, and what probably is different to enterprise environment, because people bring various devices in the network, is that usually their VPN clients on their mobile devices like iPhones or Androids get broken, because this is something that breaks in various...
VPN on Androids, we need to talk, because cases when I saw it broke, it was caused by either ESP or fragmentation case. Right, yeah, but let's talk about this, yeah.
Yeah, so basically wanted to say yes, that it works, and I would say thanks for getting all this supporting documentation. And also one more thing I discovered, that with the new version of macOS, it seems that finally DNS 6.4 is optional. So I'm personally now thinking about turning off DNS 6.4 in some future RIPE meetings.
Thank you, Apple. Really appreciate it.
Tommy Jensen. I got a chance to read one of those 2 new drafts you put out very recently. This morning, the one about recommendations for how CLAT should be activated. Huge fan, because there is some confusing points there and multiple approaches. So it'd be lovely if we all agreed that one was preferable.
Thank you. Sorry for keeping you so long.
I think that Jane have a great presentation, but I have to respectfully disagree with the #1 lesson. She mentioned, she said that having no IP address is the only way you will do IPv6. And I would disagree, because end user actually doesn't care whether it's IPv6 or IPv4. So if it's so, you can make it so easy. Like, Akamai. Like Akamai, last time in the London IETF, we have Mystic Beast sharing that, okay, because it's become relatively easy and because users have to pay for IPv4, then they may actually use IPv6. So I just don't want people to walk away saying that, oh, because I haven't run our IPv4 yet, IPv6 is not my thing.
No, people in this room, I'm not talking about them, I'm talking about organizations and management. And those people do not move normally.
I know. Thank you, folks.
I think you might say now it's easy because Jen has done it. And once she writes down how to do it, it'll be easy.
Yes. So thank you, folks.
Sweet. Oh, no. Talk to whoever you want. That sounds great. Yeah.